Today we're going to be learning Saxon Course 2, Lesson 94, and we're going to be talking about probability of dependent events. You did not just get scared at the word probability, did you? No. Remember, we're not scared. Remember, probability is just ratios, and ratios are just fractions, and we can do fractions. We've done lots of fractions, and today all we're going to be doing is multiplying fractions. We can do this. We've got this. All right, so take a deep breath. New concept, but it's not very new. We've actually seen similar things before. So we're going to apply what we know to what we're learning, and we've got this. All right, first thing you need to know. The probability that we've been doing in the past has been based on independent events. That means the probability of an event occurring was not affected by other things happening. So we didn't have any other events. We just had one event, and it was independent. And if we had two, they were still independent of each other. Today is going to be a little bit different. We're going to be doing dependent events. So it depends on what we do the first time as to what will happen the second time. So the definition they gave is the probability of an event is influenced by a prior event. Prior means it happened before. Something that happened before whatever you're doing now. So we're going to be talking about dependent events. All right, so here's our problem. We have 2 red marbles, 3 white marbles, and 4 blue marbles that are in a bag. If one marble is drawn and not replaced, and a second marble is drawn, what is the probability that both marbles will be red? Well, right now we can figure out what the probability that one marble will be red. Okay, so we're going to write the probability of one marble being red. We have a total of 2 marbles are red out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 out of 9 marbles are red. So that's our first draw. No matter what happens, 2 out of 9, that's our probability of drawing a red marble. However, if we draw a red marble the first time, that means this one is no longer in the bag. We don't put it back in the bag. It's gone. Okay, so the second time, how many red marbles do we have left in the bag? Excellent. We have 1 red marble in the bag. And how many total marbles do we have in the bag? Well, we had 9 before we took 1 out. Oops. So now we have 8 marbles in the bag. So we had 9, now we have 8. We only have 1 red marble that is left in the bag. So what we do to find out the probability that both marbles, that you'll grab out both of those red marbles, we're going to multiply our 2 probabilities together. So 2 times 1 is 2. 9 times 8 is 72. And then don't forget to reduce. So you end up with 1/36. So 1 in 36 chances of grabbing both red marbles out. So your final answer, your probability of both marbles being red is 1/36. Show that again. All right, let me do that one more time for you guys. Erase on my writing. Put my red marble back. Erase the rest of that. Okay, so the first draw, and we might even write that, first draw. That means the first thing we do, we take out 1 red marble. Okay, excuse me. We have 2 red marbles in the bag, and there's a total of 9, and we're going to take out 1. That's our first draw. Our second draw, the second time we drag something out of there, we have a total of 1 red marble in there, but there's only 8 total marbles. So we drag that out. Hello, helps if you grab the right thing, Mrs. Stoll. So we drag that out. If that happens, the probability of that happening, we multiply to find out what it is. We end up with 2 over 72 We can divide both those numbers by 2, which gives us an answer of 136. Don't forget to reduce and simplify. 136 is our final answer. Yeah, it wasn't that bad, was it? All right, let's try that again. Or try the next one. Let's do it with cards. How many cards are in a deck? Good, we have 52 cards in a deck. You might want to write that in your notes if you didn't already know that. You live in Vegas. You should know this. 52 cards in a deck. Even if you don't gamble or do any of that type of stuff, everybody here knows that there's 52 cards in a deck because you can play all kinds of games with cards. All right, what is the probability of drawing 2 aces? Well, we should know that in our deck, there are 4 suits, okay? We know that we have the hearts, and we have the spades, so I don't know if I can draw a spade. Pretend like I can. And we have the clubs. And we've got hearts, spades, clubs, and diamonds. Okay, so you have 4 suits. And each of those suits has 13 cards, one of each number, ace through king. So if there's 1 ace in this one, and 1 ace in this one, and 1 ace in this one, and 1 ace in this one, how many aces are in the whole deck? So our first draw, the first time we pull a card out, we have the possibility of 4 out of 52 of getting an ace. Okay, because there's 4 aces in there and there's a total of 52 cards. Now, if we draw 1 ace out, we no longer say we get the ace of hearts out. That's no longer there. So how many aces do I have left? Good, I've got 3 aces left. And I've taken 1 of my cards out of the deck. So minus 1 card gives me 51 cards in the deck now. So I've got 3 out of 51. So that's our second draw. So now we are going to multiply to find our probability. Now I'm going to do a little bit of reducing before I multiply, because I know that this is 1 out of 13. And 3 will go into 51 17 times. And this just gives me a little bit less to multiply. So 1 times 1 is 1, and then 13 times 17 is 221. So the probability of drawing 2 aces out of that deck is, in 2 draws, is 1 out of 221. Questions? Comments? Make sure you put them in the comment box so that I can help you. Alright, let's try another one. Back to marbles. Yay for marbles! I feel like we should go play marbles out in the backyard or something. Alright, so in a bag there are 2 red marbles, 3 white marbles, and 4 blue marbles. If 1 marble is drawn from the bag and not replaced, and then a second marble is drawn, so we've got a first draw and a second draw, what is the probability of drawing 2 blue marbles? Well, how many blue marbles are there to start with? Good, we have 4 blue marbles. And how many total marbles do we have? We have 9 marbles. That's our denominator. And we draw it, and we happen to get a blue marble the first time. So what's the probability of getting it a second time? How many blue marbles do I have left? Good, I've got 3 blue marbles. And how many total marbles do I have left? Excellent, I have 8. Okay, now I can reduce, or excuse me, I can multiply. But as you know, I like to reduce before I multiply, so I'm going to divide 4 and 8 by 4, which is 1. 8 divided by 4 is 2. 3 divided by 3 is 1, and 9 divided by 3 is 3. And then I multiply. 1 times 1 is 1. 3 times 2 is 6. So we have 1/6. Our probability is 1/6 that we will draw 2 marbles in our 2 draws. Good job. Let's try another one. All right, here we got our deck again. How many cards are in a deck? Great, I'm so glad that you remembered there's 52 cards in a deck. And how many suits are there? How many different pictures? Good, 4 different suits. And how many cards are in each suit? Good, 13 cards in each suit. That means 1 of each number, 1 of each kind, or because we have aces and jacks and queens and kings. All right. Now, remember the 4 suits are hearts, and we have diamonds, and we have clubs, and we've got spades. Just pretend I can draw a spade. All right. If 2 cards are drawn from a regular shuffled deck, so we're going to have 2 draws. First draw and second draw. What is the probability that both cards will be diamonds? Okay, well, we know that there are 13 diamonds in the deck, right? 13 cards in each suit. So 13 diamonds. So that's our numerator. Okay, and there are a total of how many cards in the deck? Good, 52 is our denominator. Now if we take away one of those diamonds, because we drew it the first time, how many diamonds are we going to have left? What's 13 minus 1? Good, it's 12. And we took away a card from our whole deck, so 52 minus 1. Excellent, it's 51. Now we can divide. So, I know that I can divide 12 by 3, I believe, would work. Let me see, 52 divides by 3. No, let's try 52 divided by 4. Good, 52 will divide by 4, and it gives me 13, and 12 divided by 4 is 3. And let's see, will 51 divide by 3? Yes, 51 will divide by 3, which will give me 1, and will give me 17, and I can divide 13 and 13 and get 1 and 1. So 1 times 1 is 1. 1 times 17 is 17. So the probability that both cards will... Oh, I missed something. Oh, Miss Stoll needs to start over again. Let's try again because I got a different answer than they did. Oh, Miss Stoll didn't get a different answer than they did. She was looking at the wrong problem. Let me show you again, just because. I'm like, what did I do wrong? I didn't do anything wrong. I did it right. I was looking at the wrong problem in the book. So let me just show you again so that you know how to set it up. And we did have the correct answer. So our first draw, we've got 13 out of 52 cards are diamonds. Our second draw, we do 13 minus 1, which is 12, and 52 minus 1, which is 51, and we're going to multiply. Then we reduced a little bit. We did 52 and 12 divided by 4, which gave me 13 here and 3 here. And then we did 51 divided by 4, 51 divided by 3, which gave us 1 here and 17 here. And then we did 13 divided by 13 right here, which gave us 1 and 1. And so we did 1 times 1 is 1, and 1 times 17 is 17. So our probability of drawing both cards will be diamonds is 1/17. All right, so if you have any questions, make sure you answer or you ask it in the comment box. And please remember that when you're doing each one, that you've either removed a diamond, or you've removed a card, or you've removed a marble, or you've removed something, and so you have to subtract that from your totals. And then the other thing you need to remember is that you multiply both draws together to find your final answer. All right, so have fun practicing this. If you have any questions, make sure you ask me in the comment box.